this video we are going to discuss about body of knowledge in the API 570 piping inspector examination. So if you go to our course and go to module 2, which is body of knowledge scoring area, for free, this will tell you role scenario, what you need to study, that complements the previous section, which module 1 about the big bucks. Module we will be talking about the area of examination and reference documents, tips on document navigation, important terms and definition, and body of knowledge. As we said before, API states that the API 570 piping inspector should have a broad knowledge in inspection and repair of piping. So as a piping inspector, you should know about API 570 inspection code, specifically an API 574 piping. Should also know about process piping, ASME B31.3, pipe flanges and fittings, ASME B16.5, welding inspection and WPS as section 9, and API 577, positive material identification 578, NDT ASME section 5, damage mechanism 571, and pressure relieving devices 576, repair of piping ASME PCC2, and finally have general knowledge of safety. API examination has two sets of reference documents as study material. One set has ASME code, section 9 welding, section 5 non-destructive testing, B31.3 process piping, B16.5 flanges and fitting, as well as the all-important piping inspection code API 570. The other set of reference materials are maybe recommended practices, 571 damage mechanism, 574 inspection practice, 576 pressure relieving devices, 577 welding inspection, 578 PMI, and PCC2 repair of pressure and piping. Most calculation type of question from API and ASME codes are in the open book part of the examination. You need not memorize the formulas, but should know where to look for when solving the open book question. So this means that you should have an idea how to navigate to them during open book part, since the search button is disabled during the exam. The advice I could give you is, when reading a code or a standard or a recommended practice, don't just go dive into it straight away. Get the bigger picture. First, understand what the code covers. So look at the first few pages. You can find the scope there or the purpose of the code, so you know what is excluded, what is included. And then next, look at the table of contents and table of list of tables and list of figures, and see how that the document is structured. If during the exam, although the search button is disabled, but list of table of contents are there, you can also have a look at the table of contents. But if you can't find what you're looking for, then go to list of figures or list of tables. They are smaller ones, and they might give you a quick hint of where you can find a particular piece of information or formula or chart or graphs. We also have flagged off these pages of codes and brought the important information in flashcards here. So these all should be treated as potential exam question. We have also timed the mock exams, complete with flagging of button and tips wherever necessary. So to test your knowledge and help you understand how to interpret and answer this exam question. the closed book exam question that are coming straight from API and ASME codes and recommended practices, or they're coming mostly within a context and scenario, are the ones that the inspector should know from the top of his head, because he or she will be using it on a daily basis. So you need to memorize them. They are called awareness type of question or practical type of question. We have also highlighted this important information as a potential exam question in the flashcards, and also highlighted them within the text and publication effectiveness sheet. The second set of reference documents contains the recommended practices, as we said. Again, we have summarized them, highlighted important information, and explained the underlying reasons whenever necessary, so you can understand the concepts. Overall, around 40 to 45% of exam questions come from API 570 piping inspection code alone. You should appreciate the fact that the 570 is an inspection code, and therefore it's mandatory, and the rest of API documents are recommended practices. They are advisory based on good engineering practice, and hence they are not mandatory. I mean, deviating from recommended practice does not violate the code. Closed book question mostly come from API 570 codes and RPs, because this type of information is supposed to be used by piping inspector on a daily basis. For open book, you need to refer to table, charts, figures, and have access to both the API RPs 570 and ASME codes during the exam. But obviously the search button is disabled. API reference materials, as you can see here, there is all these you can find in publication effectiveness sheet, and the body of knowledge, what you need to study. As you can see here, the list is, you got like a dozen documents that you have to study, and we have summarized and explained the topic and the concepts or reference material within the next 9 modules, complete with flashcards and mock exam. As we said, code is mandatory, whereas recommended practice is advisory, so you cannot violate a code under any circumstances. It's a black and white 0-1 situation. And codes are based on engineering design and calculation, while recommended practices are mostly the result of past experience gathered over the years, showing the trends. So all these empirical formulas that you see in recommended practice are, and sometimes in the code, they are actually showing you the trends. That's why that you may observe a formula brought within RPs are empirical. The empirical formulas have no scientific backing, and they are applicable under certain circumstances, and they actually show you the trends and relationship between various parameters. The reason is that it's a lot easier for people who work at the field to work with rule of thumb sometimes. And the analogy would be that you might not give the whole WPS to a welding inspector, but you might give a welding instruction which with sufficient data for the welder to know. For example, welder does not need to have access to PQR or some parameters that are detailed in WPS. All he needs to know is about what actually he is control of. That includes the range and amperage, and voltage, the welding speed, type size of electrode, the welding position, number of passes, and whether any preheat is required. So in a nutshell, empirical formulas are used when a very high accuracy is not important. For example, if you don't want to do a preheat, most of the recommended practices say is 4-inch or 40 from each side of the weld, whichever is more. So you do not really need complicated formulas to come to the right, absolute right number. Let's go to document navigation during open book examination. As you know, the search button is disabled during the actual API open book exam, so you should know where to find a particular piece of information, and for that you should know what each document covers, and on top of that which section you have to go to find it. Now there are a few hints that can help you. The most important thing is when you're solving our mock exam question, please use these codes and recommended practice and actually go to them and frequent them, and so you get the use of it or the hack of it, where you can find that particular information. So that practice helps you a lot. The second thing is, if you encounter the question that you don't know where is it in the code or recommended practice, you can go the one that you think most probably you will find the information. Look at the table of contents. If you can't find it, because the codes, some of them, especially ASME codes, they are like 1,000 page long, so the table of contents also is 3-4 pages, and you don't have much time during the exam. So if you can't find it there, go to the list of tables. They are smaller, and they might give you a hint which page you should go to, or list of figures. And again, it all helps a lot when during the actual exam, if you start practicing referring to the codes and recommended practices, especially during the mock exam or when reading our content on that particular topic. And also, as we said, get the bigger picture of the codes, especially ASME section 5, 9, E31.3 and 16.5. So look at the scope, look at the how the code is structured, you know, like for example, all welding issues are in QW, all NDT methods are in different articles, and so forth. So a bit of memorizing also is necessary, so you should know about each code and recommended practices is covering and what is the title. Hence, that's why we have explained all this again and again and repeating this, so master this. Body of knowledge, if you go to API, ICP, and there is a publication effectivity sheet which tells the list of the documents that you need to study and the revision number. The body of knowledge also lists the list of documents without revision number, but it also gives a detailed explanation of what you are expected to know as an API 570 authorized piping inspector, and it's called body of knowledge. Go to the correct revision that is relevant to the exam window. We have explained in the last video. So a body of knowledge, you should know about calculation for evaluating thickness measurement, inspection intervals, and piping integrity. You should also know about corrosion rates and inspection intervals, and as you can see here, it also refers which section you have to go to. So everything that is written in the body of knowledge, the codes and section number, they are doubly important, and you have to study them twice and be more careful here. And there would be a lot of question coming from those sections which is mentioned in body of knowledge specifically. You should know about weld joint quality factor, casting quality factor. That's coming ASME in these tables, and there might be open book question. They give you a particular material and they ask you whether this weld or cast based on the percentage of NDT done, or say machining done on the casting, or visual test done, or any other NDT done, what would be the casting quality factor or weld joint quality factor. So you have to use these tables here. And they come both in US units and metric units or ISO units. So be careful when the question comes, go to the proper table. The one is relevant to that, whether it is US units or metric units. Pressure, maximum thickness of pipe, again the section, and also here API 570 section 7.5. So section 7 is very important here, and these tables 304 are very important for calculation. For pressure testing, you go to 345.45, and it's normally about explains you if you have a hydro test, a pneumatic test, or leak test, what's the duration, what's the pressure, holding time, and the steps that you have to take. Impact testing, again there are tables, so it tells you whether you need impact testing. These tables based on the material and thickness and operating temperature, and normally you need a set of 3 Sharpie V-notch tests. And also the minimum required, you can go to table 323 for a particular material that you should have. You have explained all this in the relevant section, as well as during the mock exam we put practice questions. Preheating and heat treatment requirements, and thermal expansion. A definitive question coming from this thermal expansion, and the table that you should use is very easy, simple calculation. Simply go to the table, finding the material, and use that thermal expansion, thermal coefficient of expansion. Straight away do a simple calculation and you find the answer. Minimum wall thickness and working pressure for flanges is all about B16.5, and there are these tables that tell you each flange what is the maximum pressure or temperature, and you always jump to the next flange, and because that's a maximum it can tolerate. If the number is more than that, anything above that, you can select the flange. Procedure and qualification evaluation. This is ASME section 9, so you should know about the WPS, welding procedure specification, PQR, or the supporting PQR, they say, procedure qualification record that validates the WPS. You should know about welder performance qualification, WPQ, and essential, non-essential parameters, and type of mechanical tests for PQR and WPQ. And it only exam question only come with these welding processes: shielded metal arc welding, gas tungsten arc welding, gas metal arc welding, or submerged arc welding. And there will be only one process for this. And you should know the basic information: P number, F number. Also mention that for the purpose of the exam, the lower transition temperature is this, so this might be useful. On B31.3, these are the topics that you should look at: joints definitions, weld size, restriction on joints, and inspection requirements, preheating and heat treatment. You go to any document, it's encompassing all disciplines. So, but because this is an inspector exam, always concentrate on the inspection section of that particular codes and recommended practice. 570. So as you can see here, any rules for welding given in API 570 shall take precedence over those covering the same areas in ASME B31.3. So because it's an API 570 and because the pipe is in service, so API 570 rule applies, and if there is any contradiction between API 570 and B31.3, which is the construction code for piping, then API 570 take precedence. It's got the priority, but also you should appreciate the fact that the most of the API 570 that's coming is based on B31.3. Non-destructive examination, as in section 5. Here you should know the general requirements and the scope, calibration, record keeping. And as you can see here, for the other methods like radiography, again, you should know about the scope, the rules, the records, the procedure, and the calibration. And there might be a slight title changes on each topic, but more or less it's about interpretation, record keeping, procedure, contaminants, safe for PT. And you have the same thing for MT. Now you don't have much contamination in MT, so there is no topic here as contamination. But you have, again, you should know about the procedure, the calibration, interpretation, evaluation, documentation, and record keeping. And then finally, the visual test, same thing, and leak test. You should know about the steps, procedure, calibration, evaluation, and record keeping. And this ultrasonic standards is only for 0-degree probe, just for lamination check. But we have also brought complementary UT section, which covers other techniques of UT as well. And now the practical knowledge, they also summed it up. This is practically based on what we just discussed, but a bit of more, like you should know about organization, certification requirement, definition of maintenance, inspection, external inspection, on stream, internal, welding and piping, repair welding, then again that refers to 577, minimum thickness evaluation, remaining life, safety practices, records and reports, and repairs and alterations, and re-rating, derating, marking, material dimension test. And then specifically you should know about 570, 571, all these damage mechanism definitions and vocabulary are especially important, and all these 15, 16 damage mechanism, we should know the very basic, how it happens, what material it affects, what inspection it's required. And 574 is the inspection practice that you will be using as a piping inspector much more frequently than the API 570, because this is like a recommended practice, and this is like a guide and comes with checklist and tell you what to check, how to check, and that sort of thing. So this should be read in conjunction with the API 570, and specifically section 5, 6, 8, and 8 are important. 570, although it says the entire documents, but you do not need to be an expert in building inspection. Same as you don't need to be an expert in NDT. You should know that the general rules building inspection. 578, material verification program. 615, flange and flange fitting, as you can see here, talks about the scope, temperature, pressure, temperature rating, marking, material dimension test. So you should have the overall. And then finally, it covers the repair of pressure equipment and piping, and it covers pressure components, repair of them, alternative to post-well heat treatment, the preheat, the control the position of the well, CDW. There are different methods that you can use in lieu of the post-well heat treatment if you cannot do that, because of some weld overlay that might be damaged, etc. And well build-up or buttering, weld overlay, clad restoration, fillet weld patches, and lamps, flange repair, and non-destructive examination lieu, which is mostly in lieu of the pressure testing for repairs and alterations. So sometimes they call it the last joint, where you cannot really do the pressure test at the site. So you do like a UT or RT in lieu of the pressure testing for the whole piping system once it's been installed. Thank you. That is model 2, and we will see you on next model.